Hey guys, and welcome to a new video in this OpenCV Cuda module tutorial. In this video here, we're going to talk about like the core module of how we're using the GPU with OpenCV, how we can actually like set up the different kind of like data structures for matrices, and how we use that in OpenCV. And then I'm going to show you some examples on of like matrix operations that we can do. For example, we can normalize a matrix, we can do some thresholding, element-wise operations, and so on. So we can do a lot of different kind of operations with it. It is not only images, but it's also just matrices in general, because an image is actually like just a matrix with pixel values. But first of all, remember to join the Discord server. I'll link to it down in the description here, and you can come join the channel, chat with us about computer vision, deep learning, AI, and so on. You can now also become a member of the channel here if you want to support the channel more than you're currently doing by just watching with a small monthly fee, and everything will go to create more and better quality content here on the channel. So thank you guys. So I just wanted to show you this comparison here that I showed you in the last video, where we had this short introduction and also the documentation to OpenCV Cuda module library. So in this, we can actually see the speed up process here is really significant for the GPU, and for the primitive image processing techniques that we're going to use throughout this video, it actually like speeds up our algorithms and our operations up to 30 times. So that's a really huge and really important speed up that we can do by using the GPU over the CPU if we have a GPU available. First of all, I want to show you the documentation for some of the methods that we're going to use throughout the tutorial, because as I said in the introduction, it is really important that we learn how to use the documentation, how it's structured, how we can go in, read it, use it in our own code, and then implement it, so we actually like get a good and accurate result. Because most of the errors here when we're working with the GPU is that the data types or like the data structures is not compatible with the GPU as it were when we're using the CPU, and that is kind of what we're used to, but now we have to change over to the GPU, which is a bit different. So it's really important that we use the GPU documentation here in OpenCV, and it will save us a lot of time later on. So we don't need to like actually sit down, debug for 2 hours just to find out that we couldn't use like an unsigned integer or like something like that, and we had to use an unsigned 8-bit integer. But first of all, here we can see we have this CUDA accelerated computer vision module. In this video, we're going to talk about the core part. So if I just go into the first one here with initialization and information, we can see that we can just get some like the device info and so on. So here we can convert to floating point 16. So it converts an array to half precision floating point number. We can also see like checks whether current device supports the given feature. We can return the number of installed CUDA enabled devices. And often when I start out with a program to see if everything is set up correctly, I'm just going to like print out this CUDA device info, or like print short CUDA device info. So we get like the number of devices, we get like the version of our cuDNN, and also the CUDA version that we're using, and we also get some information about the GPU we're using. So it's really nice, a good practice to just start out with printing out the CUDA device info and see if everything is set up correctly. So the second thing here that we're going to see is some of the matrix operations. So we're going to use another data structure, as I'm going to show you in the code. So we're actually like used to using just the mat like data structure in C++. But in this video, we need to use the GPU mat to actually like be able to upload our matrix to the GPU. And then later on, when we're done doing all of our operations on that matrix, we need to download it again. So we can't just use it directly. We need to have our matrix. We need to upload it to the GPU, do all of the operations on the GPU, and then we need to download it back again to our CPU, and then we can display it on our monitor or something like that. But here we can see we have some like per element operations, some other different operations on matrices. But if we just go into the per element here, we can see that we have all of these different kind of functions implemented. We can use it both for like matrices in general, but also for images. So if we're like, for example, want to add some images, or we want to do like a different kind of like bitwise or bitwise not and stuff like that. So just all of these logical operations, we can do that on images as well. And sometimes when we're going to like threshold images, play around with those, use like a standard like ordinary like original standard computer vision techniques, we often use a lot of these different kind of like per element operations on our images. We can also divide, we can take the natural logarithm here as well. We can get the maximum value, multiply, phase. So we can do all of these different kind of things as we actually like have in, for example, NumPy if we're using Python and so on. In this video here, we're going to take the square root of a matrix because it's really efficient when we're using the GPU. If we had an application where we want to take the square root of each of the matrix elements, then we can actually like see how fast it is to do it on the GPU compared to the CPU, because the square root is actually like a really expensive operations. And also if you want to subtract two matrices, we can also do that. And we can also threshold an image if we just want to divide it into like, we just want to have one threshold value, and we can just like grayscale our image or like create a binary image as we've done on the CPU as well throughout the computer vision tutorial. But just to take one example here, if you just go into this function here, we can see that it returns a double value because this will just be like the threshold value. And we can also see like, we can see that it applies a fixed level threshold to each array element. So just go element by element and see if that pixel value is over or on this one threshold. And then we'll either set it to 0 or 255. So we actually create this binary image. We can see it takes this source image here. So it will be a single channel image. So we need to, first of all, we need to grayscale our image if we're working with color images. Then we have our destination array here, where we actually want to store the threshold image. We set up a threshold value, and then we set a maximum value to use the first underscore binary. Or if we want to do it in the inverse, we use this first underscore binary inverse. We also need to specify the type here, so the threshold type. And we need to, like, for example, we can just use the Otsu thresholding or threshold triangle as we've been throughout the computer vision tutorial. So if you want to know more details about these threshold like algorithms, you can go into the tutorial, watch those. But in this video here, or like throughout this tutorial, we're just going to use the methods, and we're not really going to dive deep into the details or the algorithms itself. So let's now jump straight into Visual Studio Code here, and this is the IDE or text editor that I'm going to use throughout the tutorial. You can also use just Visual Studio 2019 if you want to use that as instead. I recommend using Visual Studio Code or Visual Studio 2019 because those are the IDEs that I have videos about, like how we can set it up with CMake, and also how we can set it up in Visual Studio 2019. And if you haven't installed OpenCV with GPU support, just go back to those videos I have. I'll link to one of them up here, and you can just go step by step and then build the OpenCV source files with GPU support. And I'll also show at the end of those videos how we can set it up in those two IDEs. But first of all here, I'm just going to include all of the modules, all of the CUDA modules. We're not going to use all of them here in this video, but we're going to use all of the modules here throughout the whole tutorial, because we're going to have this like full course on CUDA, the CUDA module in OpenCV, so we can know how we can use it, and we just have like really good sense about how we can use the different kind of methods, and also all of the different kind of modules or sub modules that we have inside of OpenCV Cuda. But first of all, here we just have some, for example, like CUDA image processing. We have the filters, we have the background segmentation, some codec here to actually like have video input and output, object detection, optical flow, stereo vision as we're going to use. We have some features, so we can actually like have some feature detection, and also warping, where we're going to use affine or like perspective warping to actually like transform our images. But in this video, we're mainly going to focus on the core CUDA and also the CUDA image processing up here. So you actually like only need to have this include CUDA core and also the image processing module up here. So first of all, here we're just going to use the namespace SD, and we're also going to use the namespace CV. I'm not going to use the namespace CUDA because when we're going to use the methods from CUDA, we're just going to type out CUDA and then colon before we're using the methods. So we actually like know when we're using methods from the CUDA module and not just from the like the standard OpenCV module on the CPU. So as we always have done here, we're just going to open up this video capture, and we will call it cap, and we just take the 0th element because this will be the first webcam that I've connected to my computer. And then first of all here, we just go inside our main function. We're going to have this while loop here that is just running while the webcam is open, and then we're going to read in all of these individual frames. But first of all here, we need to specify like the matrix. So we need to make a matrix for the CPU that we can show later on, and we also need to set up some matrices that we can use on the GPU. So first of all here, we're going to take like the ordinary matrix that we already know. So we're going to have this mat im. So this will just be the image that we're going to use on our CPU. And then we also need to specify this CUDA. And then inside of CUDA, we can actually like take the GPU matrix. So this will be the matrix that we can do operations on our GPU. So we're going to call this im GPU. And then we also need, when we're going to split and merge our actual like channels in our images, because this is one of the functions or like methods that I'm going to show you, then we will need a vector of these matrices. So first of all, here, we're going to create a vector. And inside of this vector here, we're going to have these matrices that we can use on the GPU. So we'll call this GPU mat. And then we'll just close the vector here and we just call it GPU mats. And then the last thing here that we want is just like a matrix that we can store some like results on later on. So we're going to have the CUDA, and then we just take the GPU mat here again. And we're just going to call it mat for some temporary results that we're going to use. Then we can just, as I just mentioned from the documentation, I like to start out with just printing out some CUDA device info so we know like what is going on. I'll just copy this down here to the comment so we can actually like follow along. And then we're just going to print out the GPU information here at the start. So from the documentation, we know that we go inside of the CUDA module, then we can print CUDA device info. We can also print the short information, but we're just going to take the zeroth element because I only have one GPU connected to my computer. So we're going to use that in this example. So now we have actually like set everything up and initialize both the variables and the matrices that we're going to use. So now we can actually go down to our while loop here, and then we're just going to run this while loop as long as our webcam is open. And at the end here, we just have a wait key here checking if we hit Q on a keyboard, it will like go out of this while loop here, and then it will like release our webcam and it will restore all the windows that we have opened up. We're also going to track how long it actually takes to run the algorithms. So we're going to have this tick counter, which we just call start. And at the end here, we're going to have an end tick counter here, so we can see the number of frames per second that we get by using these methods here on the GPU. And then later on, we can compare it to the CPU. And then we're just going to calculate the total time here, which will be the end time minus the start time. And then we divide that by the tick frequency that we have here in C++. And then to get the actual number of frames per second, that will just be 1 divided by the total time. We're going to put out the number of frames per second on our image before, while we're showing it, so we can see the number of frames per second that we get by running these different kind of operations on our images. And as we know from the comparison, when we're using like these element-wise operation and just like standard matrix operations, we can speed up the process up to 30 times compared to only using a CPU. So here, after we've read in the image from our capture, as we have done in all the other videos throughout the computer vision tutorials, we actually have stored our image here in this image variable, and this is just a standard matrix, so this will be only working on the CPU. So first of all, as already mentioned, both this video but also in the introduction, we need to upload our image, or we need to upload our matrix to the GPU matrix, and then we can do the operations on the GPU, download it down to our CPU matrix later on again. So here we're going to have this im GPU, which will be the GPU that we can use, or like the image that we can use on our GPU. Then we're going to have this dot upload. So we're actually going to upload our image. And then we need to specify what image do we actually want to upload to our GPU. So now we have actually uploaded our image to the GPU with this line of code. And now we can actually go down and do the image operations that we want to do. So here we're just going to take the CUDA module. And then inside the CUDA module, the first thing that we're going to do is actually grayscale our image. So here we're just going to use the CVT color as we already had done in the CPU version. So all of these methods, they have the same name as in the CPU versions. You just have to specify this CUDA here before. And if you're using Python, you can specify CUDA dot and then the method that you want to use. Or if you actually import CUDA from OpenCV 2, you don't even need to specify that you're using CUDA as well, just as if you're using namespace CUDA here in C++. So here, when we're going to convert our color, we need to specify the GPU that we want to convert the color from. So we have the source, and then we also need the output. So we're just going to have it in the same matrix. So we're just converting that from BGR to RGB. Then we need to specify what do we actually want. So we want to convert it from BGR to grayscale. So this will be this flag. So So now we've converted our image into a grayscale. We can actually just run the image or like the program here to see if everything actually like works. So here we're just going to build the program. It will set up and build like CMake here from the source files. We can see that our build finished with execute 0. And now we can run the program and see if it actually like works. And if we're able to upload our image, grayscale our image, it will actually like not work here. You can see that it's not grayscale because I forgot something. We haven't downloaded our image here to the CPU again. So here at the bottom, before we actually like ending our timer, we need to go in here and use this Cuda or like imp GPU. And then we need to actually like download it to our image again that we can then show with our image show later on. So this will be the image that we're going to download it to, and then this will be the image that we're going to show with our CPU. So now we can build our program again and run it, and it will like grayscale our image. So now we will just open up. We can see we get this device info as we did in the previous videos. So we can see that we, for example, have like the CUDA driver version, the cuDNN version, and so on. We can also see what type of GPU is GPU. So this is the 1060, 6 GB of RAM and stuff like that. But here we can see we're actually like grayscaling our images. Sometimes the FPS here actually like flickers a bit because we're also timing the upload and the download of our matrix to our computer here, or like to the GPU as well, which sometimes like tricks that is frames per second here, but we can still get like an intuitive or like kind of like an estimate of what the number of frames per second that we get, or we could take it like an average over time as well. But now we can see we can use the GPU to do the actual like grayscaling of our image here, and this is actually like the result that we want, and we also get the information out about our GPU. So now we can go in and actually like do some more operations on our images. So first of all, here we can just try to use like, for example, transpose. We're just going to specify CUDA : transpose, and then inside this transpose we can see that we need to specify our input image, and we're also going to specify our output image here as well. So now we both convert our color from BER to grayscale on our GPU, and now we're also going to transpose this. So I'm just going to build a program here again and run it so you can see like what is going on. So this will actually like correspond to actually like rotating our image a bit, because we're just taking like, for example, we can see here that we take like all of the rows, and those will be the actual like columns now, or like the other way around. So all the columns would be our rows, and the other way around. So here we can see we have actually like rotated our image here 90 degrees. And if we're going to use like transpose one more time, we will just rotate it here again. So now we can do all of these different kind of operations, and you saw all of the operations that we can do in the documentation. You just need to use it as with the CPU. We just need to specify CUDA, and then the method here that we want to use just as the CPU. Just make sure, go into the documentation, see if that method that you want to use is actually like implemented. It's actually like implemented for the GPU, but also if you have the correct data type for your matrices that you're inputting to the function. So another thing here is that we're going to see the split here. So how we can actually like split up these 3 individual channels of our image. So now we're just going to comment out this one out here. So we're not grayscaling our image, but we still have 3 channels in our image, so we can actually like split them and then merge them later on. So here we're going to use CUDA again, and then we're just going to call the split function. We take the input image, and then we need to specify the vector where we actually like want to store each of the individual channels in our image. So this will be our GPU mats. And this is the vector that we created up here at the top. So we have a vector of CUDA GPU matrices, and we call that GPU mats, which will be the output, and it will contain like 3 individual like channels of our image. So we actually like splitting our image from BGR. So it's a 3-channel image. We split that into 3 matrices. So we have one matrix with the blue color, one matrix with the green color, and one matrix with the red color. Then we can do operations on each of the individual channels, and then later on we can merge them back in, and that can be used for a lot of different kind of computer vision like techniques and operations. So here we're just splitting it, but then we can actually like just try to see out here. So we're going to see out our GPU mats.size, so we can actually like see that the size will be 3 when we print it out. We're going to end the line, and then afterwards we have done that. we can just use this merge to actually like merge all of the channels together again. And when we merge them, we specify here the inputs, so the three matrices that we want to merge together again to a single matrix, which will just be stored in the image GPU here again. So at the end here, we haven't really done any operations except splitting the matrices and merging them together again without doing anything. But this is just to show you like how it's done, how we can access the different kind of methods. And we can also see here that the size will be 3, and then later on here, after that, it will actually like be 1 again. Or like the 1 here, it will be combined in this image GPU here. So when we're done this here, we can just build a program, run it again, and see what it actually like does. So here it will open up, it just keeps out printing 3, 3, 3, 3, and now we actually like have our image up here in color, because now we're not grayscaling it anymore, but just keeps out printing out 3, because every time we load in an image, we split it up into 3 individual channels, and then we merge them again, and then we show it here on the computer. So this is just to show you like what we can actually like do. So if you want to do some operations on the individual channels, you will actually just do it in here. So we actually like just do it in here in these lines of code before you're merging them together. It could be, for example, that you want to like take the square root of all the green channels or all the green values in your image. You want to take the square root of that, or like some other different kind of things that you want to do on each of the individual channels in your image. So if you want to like just take them out, do something with all the red colors and stuff like that, like it could be used in a lot of different kind of projects and applications within computer vision. So the next thing here that I want to show you is actually like that we can use some of the other different kind of methods. We can also use, for example, the split method. So it will just be the exact same thing. But now we're actually like just going to get down here to the element wise operations as we saw, and we're just going to take one example because I showed you the functions in the documentation, and it's actually just calling the functions, taking the input, specifying the output, and then we can just show it. But now we're just going to take like a threshold value. So we're going to threshold the image with some threshold value. So here we're just going to specify Cuda threshold as we've done in all the other examples. And here we need to specify the input array. So that will be our im GPU. And then we need to specify the output here as well. And it will also be our im GPU. We need to specify a threshold value. So we'll specify here 100. So if our pixel value is above 100, then it will be 255. And if our pixel value is below 100, it will then be a 0. So we're thresholding our image into either 255 or 0. So it will either be like white or black pixels in our image, depending on this threshold here. And this is just the value that we want to like set our value to if we are above the threshold value 100. So this is to binarize our image. And then we want to specify how we actually want to use it. So we're going to normalize the image with the min max value. And at the end here, oh, that's not here that we're going to specify that. We need to specify the fresh binary as we saw in the documentation. So here we're going to have fresh binary. And if you want to do the inverse, you can just hit underscore in inverse here, and it will then take the inverse, and it will be the opposite of finding the threshold value, or like setting this threshold value here to 255 if the value is under 100 instead of above 100. So here we're just going to threshold our image, and then we can just build a program, or like build a program here and run it again and see this threshold, how it plays out with the camera. So here we're just going to open up the GPU again. We see that now we're actually like thresholding our image here. We can also see that sometimes it doesn't actually like set it to 255 because we've only specified this fresh binary here. But now it actually just goes in, looks at all of the operations, or like all the elements in our image. It then goes in and actually like threshold our image. We can't do it here because right now we're operating with 3 channels our image. So if we were going to do it actually like to set it either to 0 or 1, we need to first grayscale our image here. So if you just comment this one out up here, build our program again, then we only have 1 channel to look at a time. And we also sort that in the documentation as well, that this threshold value only works, or like this method only works on grayscale image or single channel images. So here we're going to run it again. We can see that now it actually like works pretty good. We can see it is white, all the pixels that is under 100, and all the pixels values that is above 100, it will be black. So here for example, the black TV in the background, and also the black chair is also still black because those values is under 100. So we can do a lot of different kind of things. And thresholding is also really fast by using this GPU, because when we're talking about image operations like pixel by pixel, we can speed up the process up to 30 times by using the GPU over the CPU. We can also use a lot of different kind of other matrix operations, like we could, for example, try to normalize our matrix. So if we want to normalize our matrix, we can just go in again, use the Cuda. And then inside of Cuda, we just call normalize, and you can find all of these different kind of things. You can take the absolute value, you can take the square root, you can normalize it. You can do all of the different kind of matrix operations that you can also do in NumPy. But in this video here, we are just like in Cuda module, you're using the GPU instead of the CPU. So the operation is just really, really fast. And if you're going to use some really large images with a lot of different kind of pixels, or you're just going to use a lot of those operations, it will be much faster, and you can actually use it for real-time applications by using the GPU over the CPU. So this is the last thing that I'm going to show you here in this video for the image operations. So this video is more about like what different kind of things can we use, how can we use it, how can we access these different kind of things, and also how can we use the matrices on the GPU and then do the operations, download them again, and then in later videos we're going into more details, more like nice stuff, not more like the basics, which this video here was about. So we're also going to use the method for stereo vision to find disparity map, to find like depth and distances to different kind of objects in our environment. So we can use all of these nice cool things as well, and we're going to cover that in other videos, but we need to get the basics done here first. So this is just the last thing here that I'm going to show you. So this will be the image GPU. We're going to specify the values where we want to normalize them for. And here we need to specify like the normalize. So we take a min max value. So we like to like be either 0 or 1 when we're going to normalize our matrix here. So we're going to normalize all of the individual pixels in our image. Then here we also need to specify that we want to use CV32F. So we want to use a 32-bit or like floating point number. So we need to specify that as well. And this is one example of like, this is really important that we're going into the documentation and see if this data type here is actually like supported for this method in the Cuda module in OpenCV. So this will be the last thing here that I'm going to show you. We just need to end it off here with a semicolon. So now we're just going to build a program here for last time, and then we're going to run it, and then we're going to end off the video here. So now you know the basic operations and the core part of OpenCV Cuda module. So we're just going to run here. It will open up Cuda again. We can see that now we actually like get the image up here, and we have now normalized our values to either 0 or 1. So this is corresponding to doing the actual like grayscaling of our image. So thank you guys for watching this video here, and remember to subscribe button and bell notification under the video. And also like this video here if you like the content and you want more in the future. I'm just really excited for this Cuda tutorial because it can just really speed up, and we can create some really nice real-time applications with the methods here from OpenCV. It's just really nice, really cool. And again, these were just the basic operations that we need to get straight on with. And then later on, we can use the more complex and more detailed stuff that where we can actually create some of the nice and some of the cool things within computer vision. So thank you guys for watching. I'll link to the computer vision tutorial up here, or else I'll see you in the next video, guys. Bye for now.